welcome to today's video. Today we are looking at force and acceleration. And to start with, I would like you to pause the video and work out the resultant forces in each of those diagrams. Okay, so for the first one, you should have got 5 plus 5 gives you 10 newtons to the right. Second one, 0 newtons. The third one, 15 newtons to the right. And the last one is either minus 5 newtons or 5 newtons to the left. Okay, so moving on, we've got an equation. It's one of the ones that you have to memorize. F equals ma, or force equals mass times acceleration. Force is measured in newtons, mass in kilograms, and acceleration in meters per second squared. So if we were to rearrange that, we would get acceleration is force divided by mass, and mass is force divided by acceleration, and those will come in useful. Okay, so here are some practice questions for you to do. Again, I'd like you to pause the video, try and answer them, and then we will go through the answers. Okay, so in question 1, we are after the force. What force is being applied? So we're going to use F equals ma. So the mass is 10 kilograms times the acceleration is 16 meters per second squared. So 10 times 16 gives you 160 newtons. Question 2, again, we're after the force. So we're using F equals ma. So our force is going to be equal to a mass. Now we have to remember to convert the mass to kilograms. So that's 0.14 times by the acceleration of 10, which gives us 1.4 newtons. Question 3, we're after the mass. So we want to use mass is force divided by acceleration. Our force is 24 newtons. So mass is 24 divided by an acceleration of 0.5, which will give us 48 kilograms. Okay, and then for question 4, again, we're after mass. So mass is force divided by acceleration. That gives us 4 divided by 12. Which is 0.33. Remember, we need to round. So that's kilograms. Okay, here's some more questions. So our first one, we want acceleration. So acceleration is 3,200 divided by 16, which gives us 200 meters per second squared. Can you pause and have a go at the other two? Okay, for the second one, you should have used the same equation again. Acceleration is equal to 60 divided by 120, which is 0.5 meters per second squared. And for question 7, again, we're after acceleration. Force divided by mass. The force is 1.8. Now the mass, remember, we need to convert for this one. So that's 0.02. And that gives us an answer of 90 meters per second squared. Okay, what we're going to do now is just this little bit for higher tier. So for higher tier only, inertial mass is how difficult it is to change the velocity of an object, and it's equal to the ratio of mass divided by the ratio of force divided by acceleration. Okay, so in a moment we're going to do a practical, so I'd like you to copy out the table so that you can put your results in as we go through the practical, please. So pause if you need to, and then we will continue. In this video, we're going to look at how the force pulling a trolley affects the acceleration of the trolley. Okay, so we are going to start. We've got our trolley. which is going to be pulled down by a mass on a spring that is going over a pulley, and the pulley is there to reduce the friction. Now I've got two light gates being held up by the more traditional clamp stand and a robot arm, because you have to make use of what you've got lying around the house. And those are connected to a data logger. And the way they work is when the card that's on top of the trolley passes through them, they detect that motion, and then the data logger works out how long the card takes to go through each one, and then as a result of that it can work out the acceleration. Okay, we're starting with 1 Newton on the end, so let's see how that does. Right, that gives us an acceleration of 1.47 meters per second squared. We got 2 newtons this time. And that gives us 2.77. Gives us 3.97. So we've got 4 newtons this time. And that has given us an impressive 18.30 meters per second squared. 5 newtons this time. And that has given us 4.93. Okay, this one we've got 6 newtons on. And I'm starting to worry about my wall. And that one was 5.42. And I think we're going to call it a day there before I start suffering from structural damage. So now we've got a set of results. What we need to do is produce a graph of those results. So I've got a bit of graph paper, ruler and a pencil. I'm going to start by drawing my axes. We're going to put force in newtons along the bottom, and we need to go up from 0 to 6, so 1, 2, 3, 4, 5, 6. Now I've not used every single box because I'm trying to use as much space on the graph paper as possible, so I'm using every 2 boxes. But we've got to go up to 18.3 for the acceleration. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I'm going to have to use 1 box per meter per second for the acceleration. I'll start by putting in and the units, meters per second squared. Okay, and then we can go up 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so for 1 Newton we had 1.47, so that's about 1.5. So a little cross at the 1.5. At 2 it was 2.77, so we're going to round that up to 2.8, 2.5, 6, 7, 8, and across there. At 3, 3.97, so we round that up, that's 4. Then at 4 we had 18.3, so that goes up there. At 5 we had 4.93, so that goes to 4.9, and 6 we had 5.42. 0.4 is there. Okay, so right at that point my video stopped recording without me noticing, so I'm just going to talk you through how I got this line of best fit. And first of all, I'm going to talk about the anomalous result. So I've circled the result at 18.3 because it's very obviously anomalous. You won't want to include it in your line of best fit. So that leaves us with 5 points. We want a split of 3 and 2, 3 above, 2 below. You move your line until it's in the right place where there's an even number of points either side of the line, and then you draw it in. Okay, this might have been a curve instead. you also need to look, you can draw a freehand curve instead of a straight line of best fit. So what we need to ask is the relationship directly proportional? Is there a straight line of best fit? Well, in my case, I did draw a straight line of best fit to it, so that would be a yes. Does the line of best fit go through the origin? No. So from my results, these aren't directly proportional. That's what we would expect, that it would be directly proportional. So what we need to consider is, why isn't it directly proportional? And I think the reason for that is probably because of the amount of friction between the trolley and the table, which increased as we increased the mass. So that would have reduced the amount of acceleration. Okay, I've got some questions on Fronter for you to have a go at, and good luck.